So after your ChimeraX is installed, you can see the desktop icon. So we can click here to start. Remember, the ChimeraX actually involves a lot of graphical things. So sometime it may be slightly slower to start. So be patient with it. Now once the ChimeraX is there, you can actually go to the tools and see if the ACQ Pro is installed or not. In my case, it was already installed. If in your case it's not installed, you can go, let me show it again. You go to tools, more tools, and from more tools it will get loaded, and here is a ACQ plugin, so you can click here to install it. In my case it's already installed, so I'll just use it. And this plugin actually allows you to do a lot of nice stuff, including making structure, making input file, analyzing output files, like that. So let us start with a very simple example. Let us go to the structure builder. So structure editing 2D builder, if I open it, so here you can draw molecules pretty easily and will show how to convert them into 3D structure. For example, if I am interested in drawing chlorobenzene, so it's there, I put a ring here and the carbon I should replace by chlorine. Now once this is done, so this is a 2D structure, I will convert into 3D, and before that I will optimize it with AN1. Some issues, so for the time being I will not do the optimization. Yes, the structure has not came properly. Okay, so what I can do, I can go to tools, I can go to the structure editing 2D builder. 2D builders actually allows you to draw molecules pretty quickly by using the custom templates. So for example, if I want to draw a benzene, maybe a chlorobenzene, and now we'll open the molecule, you see a chlorobenzene has been drawn. Now I can close this one for the time being. Now I can make Orca input file by two different ways. First of all, I can save this one in an XYZ coordinate file. So I go to my computer, Windows, somewhere there will be an user. Here is my NPTEL week 2 and let me save it with chlorobenzene. So here you see that there is a chlorobenzene.xyz file there, and I can prepare an Orca input file manually by hand. Up to now we were making the input file mostly by GUI, but remember it's possible to make an input file by hand also. So the way I will do is that I will open a new terminal, a notepad terminal. I will go to the formaldehyde input files. I will copy this line I'll paste it. So it's contain RHF, single point calculation, depth to SB basis set, large print for showing the molecular orbital. And instead of giving the Cartesian coordinate into the file directly, what I can do is that it can take the coordinate from another file which needs to be present in the same directory. So in my case, the name of the file is chlorobenzene.xyz. So if I go to the property of this file, you will see that it's a .xyz file. Remember, this XYZ file needs to be present in the same directory where your input file is. So now I will save it at so now we'll open in terminal. Maybe I'll increase the zoom a little bit so it's more easier to see. And I will save it with the same name. So it says that it cannot open the input file. So can be a common problem. Maybe we have not saved it in a proper place. Yes, we have not saved inside the download, not inside this directory. Here I should have saved it as chlorobenzene dot. So this mistake can happen, that you by mistake you save it on a different file, and then the Orca will say that okay, it has not able to get this input file. Now let us try. And you see the error, cannot open the input file. Now it says that it cannot find the chlorobenzene.xyz. If I do an ls, there is a mistake in the spelling. So this also you need to be careful that the spelling of the XYZ file we have written as CHOLO. So you have to make sure that you have to keep the spelling same. So whatever is the spelled name of your file here has to be same here. So good idea is that I will just try to copy it. Or maybe I should copy it from here. This is the file name. I'll go to properties. I'll find the exact name. So remember, you can get a lot of these errors if you are not careful with the naming, extra space, underscore. If they are not correct, then this can lead to errors. So now I believe it's saved. Now let's run it again. So this kind of troubleshooting you have to do once in a while. Let's try to save it. Still cannot find it out. What you can do is that you can directly prepare the input file by going to quantum chemistry, build QM input. So you can directly generate Orca input file. You can put it the memory, processor, what method you want to give. For example, in my case, I would want to use restricted Hartree-Fock for the basis function. I want to use def2 SVP, and this should be fine. Additional keyword, maybe I can modify it later. So after I am done, I will go to save input. I can save it as chlorobenzene. So the input file is there. I can put the option large print, but not need for the present case. So here the calculation is running, and once we are done, we can open the output file. ChimeraX also have many other features. For example, in addition to the 2D builder, it can actually do a lot of other building stuff. For example, you can actually prepare inorganic complexes. You can actually directly prepare organic compounds if you know its IUPAC name. For example, if I let me close this view. For example, if I want to prepare, let's say, the structure of the organic compounds orbital. This is how the compound looks like. And if you look at Wikipedia, orbital is a sweetener which is used in many of the gums and food products. And if I find out the IUPAC name for it, so this is the IUPAC name for sorbitol. Those who are better in organic chemistry than me, they can find it more easily, maybe not searching from the Google. So I can directly get the structure of this orbital by putting the IUPAC name. And this is the structure would look like. And I can of course prepare an input file going to the same tools, quantum chemistry, build QM input like that. You can also make inorganic complexes. Let me close this one and then we can go to the inorganic complex builder, structural editing, and this is a coordinated complex generator. Let me generate a cobalt complex, an octahedral cobalt complex, maybe with some bidentate ligand. And here you will see the selections of the ligand possible. I will choose the ligand by denticity, and maybe I would love to have a bidentate ligand, maybe EDA. So it's an octahedral complex, so I have to fill up at least 6 position. So let me put EDA, now it's 4. So now maybe I want to add some chlorine. This I again need to change, and this time I want the denticity to be 1. This is bromine, chlorine should be somewhere below. Here is the chlorine and another chlorine. So this will become 2-chloro 2-bis cobalt EDTA complex. Now here you see that the structure looks slightly odd. Why it looks odd is that because this complex can have multiple symmetries and it has generally ChimeraX generates all the possibilities. So if I am interested in only very few of these symmetries, what I can do is I can close, no, I don't want to close all models. I want to close this to one only. Oh, my everything got closed. Let me do it again. Complex generator, I go to cobalt. So for the cobalt, I can now generate the ligands. It's an octahedral complex, so it will have 6 positions. So let me choose a bidentate ligand. Here the list of ligand will come. From the denticity I can choose them. So let me choose the bidentate ligand EDA. Done selecting the ligand, I add another of it. So now it's base EDA. I have 2 more position left. So I add ligand here. Maybe I want to add a monodentate one here. Oh, must be somewhere up. This is Cl, and let me add another Cl. So my 6 positions are now filled. I can create the coordinate. Now the structure may look little bit odd. It looks odd because it can have multiple symmetry possibilities when you create them, and it actually has created all of them. So you need to choose the structure we want. For example, I want it to be the D2H structure, so I'll close the other ones. select. So let us close one by one. I close this one, I close this one. So now I am left with the D2H structure. Once I have the D2H structure, I can again go to the quantum chemistry tools, build QM input, and actually make the QM input out of it. So this actually gives you a very powerful tool to actually generate and modify input files. Not only that, it can also open your output file and help you to visualize the orbital. For example, we have run the formaldehyde example. I can now open it. The formaldehyde.output, it's on the same folder. It's an Orca output file. So I select the Orca output file. Of course, I have to make sure that this one is no longer visible. So this is how the structure looks like. Now to visualize the orbital, you have to go to quantum chemistry and orbital viewer, and here you can see all the occupied and unoccupied orbitals. For example, if I want to see the HOMO, this is how the HOMO looks like. So the pictures are quite nice. Not only from orbital, it can also seek IR spectra, NMR spectra, UV visible spectra, vibrational spectra, many of this GUI can do, and we are going to use this GUI to visualize many of the output files when we will run more and more Orca calculation. And my chlorobenzene job is going on. It will take some time before it finishes. So once it's finished, we can see its output file if we require it.